Question 15 is 4 marks. The question has 2 parts. Part A. Root 3 to the power 5 is equal to k root 3, where k is an integer. Find the value of k. There are many ways to do this. Let's do it the fun way first, and then let's do it the indices way. The fun way is it's just fun. What's root 3 to the power 5? To the power 5, that means root 3 multiplied by root 3 5 times. So this is root 3 times root 3 times root 3 times root 3 times root 3. Now, root 3 times root 3 is always 3. And root 3 times root 3 is 3. So 3 times 3. And then we have this root 3, we just write it here. And that's equals to 3 times 3 is 9, so it's 9 root 3. The value of k is 9. And that's it. The question asks you to find the value of k. That's 9 root 3. This is it. This is the easy way. Now, if you want to do it the indices way, you can say root 3 to the power 5 equals root 3 is 3 to the power of a half. Root anything is just that thing to the power of a half. Let's just write it inside the bracket. So root 3 is 3 to the power of a half, and all this to the power of 5. Now the indices says, if you have 2 indices, you multiply them, right? So it's going to be 3 to the power of a half times 5 is 5 over 2. Now, this will give you, let me just move this up. It's very slow, I don't know why. Now, this is going to give you 3 to the power of 5 over 2. We can just plug this in the calculator and it will give you 9 root 3. At this point, that's enough of a lot of work, and that's enough. If you'd like to do it another way, it's going to be the 5th root of 3 to the power of 5, and then this is the 2nd root of 3 to the power of 4 times 3. 3 to the power of 4 under the square root is 3 squared times root 3, which is also 9 root 3. So there are many different ways. For me, I like this one. It's fun, it's easy, it's just relaxing. Now let's look at question B. Show that 21 divided by 3 minus root 2 can be written in this form where C and D are integers. Once I marked the student's paper and the question says, I think C or whatever letter, they said the letter should be a prime number. And the student got an answer of 8.2, I remember. So it doesn't make sense. Always, please try to make your answer make sense. If the question says C and D are integers and you got a decimal, redo the question. It's wrong. Now let's do this. First, let's write it 21 divided by 3 minus root 2. Whenever you have a surd down there, you multiply by the conjugate. You rationalize the denominator. So we multiply by 3 plus root 2, multiply by 3 plus root 2. The conjugate is when you change this sign. If it's negative, you make it plus. If it's plus, you make it negative. Now let's multiply. 21 times 3 is 63, isn't it? Plus 21 times root 2 is 21 root 2. That's good. Now, the denominator is 2 brackets multiplied together. So, we do FOIL. 3 times 3 is 9. And then 3 times root 2 is 3 root 2. We finished with the 3. Now, root 2 times 3 is 3 root 2, but there is a negative sign, so it's going to be minus 3 root 2. And finally, root 2 times root 2 is just 2. because this is negative, so it's going to be minus 2. Now, this will cancel. 3 root 2 minus 3 root 2. Now, up there on the denominator, we can't do anything for now. Let's just leave it. 63 plus 21 root 2 divided by 9 minus 2 is 7. So the denominator is just 7. Have you noticed that 3 of them can be divided by 7? So let's divide here by 7, divide here by 7, divide here by 7. Now, 63 divided by 7 is 9, plus 21 divided by 7 is 3, and then root 2. In the denominator, 7 divided by 7 is 1. We don't need to write it. So this is 9 plus 3 root 2, and that's proved. That's it. Now, question 16. What's this? Oh, functions. That's fun.